Artificial intelligence will impact all of our lives and how we work. IFS.ai is industrial AI. It's the thread of intelligence flowing through your business in a world where data is everywhere and informs the lifeblood of your company. The thread that powers decisions made by humans or machines. The thread that revolutionizes your operations, optimizing your people, assets, and service. The thread that enables the world's most progressive organizations to contextualize intelligence, simulate outcomes, automate production, and drive innovation across your business at pace, safely. We're going beyond co-pilots. We're powering intelligent business. IFS.ai, industrial AI that enables your business to thrive and grow.
Good morning, everyone. Welcome to CodeRally 6.0 Workshop 1, Understanding the Competitive Programming. I am Kanushan, and I will be a moderator for today's session. It's such a pleasure to have all of you here with us as we kick off this exciting journey. I am truly honored to be a moderator today and help guide you through this insightful session. You get a glimpse of everything that's coming your way, from engaging workshops and hands-on experiences to a reimagined competition format designed to give every coder a chance to shine. So let's dive in and get started. We are delighted to welcome today's first speaker, Mr. Ramindu Valgaman, data scientist at IFS, who will be guiding us through the theme, Understanding the Competitive Programming. With years of experience in organizing competitive tech events and empowering student communities, Mr. Ramindu brings valuable insight into what makes CodeRally 6.0 a game changer. Let's welcome Mr. Ramindu Valgaman to give his exciting speech.
morning to you all. So let's get started. CodeRally 6.0. So I'm here to speak about how to break down that code not a code, but the problem that you've given, and how to understand the question. So I will be going through with some of the examples, and as well as some tips for you. So let's get started. I'm Rahul Vagam. I'm a data scientist at IFS R&D. So I'm actually from two alumni from University of Westminster in IIT, as well as University of Colombo School of Computing. So with that, I wanted to give you a motivation why you do this, why you should start this. Because back in 2020, in February 21st, I started just a random senior when I was in first year. Just a random senior came to me and asked to participate in Google Hashcode. I didn't know what a Google Hashcode was. It's just a competitive programming competition, which is not available, I think, at now. They are not telling it anymore because of the libraries of AI. So just a random senior, second year, came to me and asked to participate in a coding competition. I didn't know what it was actually. So the person who is next to me was another first year. We both didn't know how to code properly, but we were able to understand and break down the code. So this photo was taken after the Google Hashcode. It was like Google Hashcode is held by Google. It is an international competition. A lot of competitors participate. Around 1,000 from Sri Lanka. It is more than 1,000. So it is like IEEE Extreme if you have participated. So with that, this is IIT hub. There are a couple of hubs over there in Moratuwa, UCSD, and all across Sri Lanka. So, and there were no age restrictions, so I was just a first year. So with that, I participated randomly, and this was started around 9 a.m. So if you can see the time, it's like around 2:38 a.m. So it was went around 6 hours from I think 9 p.m. it started at the IIT other building, and we participated, and you can see that it takes it 21 minutes, that means we were in at 3 a.m. So when we participated, and we were able to get 20 million points. There are no limits to points, we can take as many as can if we come closer to the answer. So that is the difference between Google Hashcode and the competitions that you participate, because if you are hacker rank, you are given many problems to solve at the given time, but this is, they are giving a real world problem, and we have to get the answer closer to the what they have expected. So if we are closer and optimized and less memory usage, then you are getting higher points. So I was the first year, right? I didn't know how to code, but when the results come, we were in the top 25 in Sri Lanka. Sri Lanka. It's just my first hackathon, but randomly I became 25th in, our team became 25th in Sri Lanka. It was around 4,000 in online. So with that, we after 8 days, was another competition on February 29th, 2020. So that is called ASS Coders. I'm telling you this to give you a motivation to start competitive programming. So I was 25th in Ireland, but I participated 100 teams. There were 100 teams. I participated in this team, and guess the rank of my team. It was 100 teams, but we were around 70s or 60s. But before that, we were around top 25, all island across. There was no age limit, but this time we were 60s or 70s. As I can remember, it was 72 or something. So that is because I was not able to understand the questions. Sometimes I'm loaded with a lot of questions, but I couldn't able to solve it any. So because of that, we were 70 something. So after that, I participated in a lot of competitions, including OpenHack, the we won sometimes, we lose sometimes, but doesn't matter. We kept on going. I was in a couple of teams. This is Team Citizens from BCSC, and participated a lot of collections. This is Vertically Extreme. I won't highlight that. I will tell you what is Vertically Extreme in short. So we participated many times. I participated at Vertically Extreme 3 times, I think, during my undergraduate. So sometimes we won and sometimes we lose, but it doesn't matter. We kept on going. So this is my journey. I give you this. You start your journey. So you could be a first year, you could be a third year, doesn't matter. Participate multiple hackathons as you can because it is a learning curve. There is a learning curve that you can get. So with that, why competitive program? In the competitive program. So I prefer Python. It is not a mandatory. I mean, you can do it in any language that you wish. But I choose Python because it is easy to use. I mean, it is more human friendly. And data structures and algorithm, it is a must. Without knowing data structures and algorithm, you cannot able to do competitive programming. So, and practice. As I mentioned earlier, practice more as you can. There are hacker rank and lead code. Lead code is a bit harder than hacker rank. And code forces, CS Academy. CS Academy contains IEEE Extreme past questions. And if you are interested in IEEE Extreme, IEEE Extreme is a competition like this one, 24-hour hackathon. It is an international one, so all across universities will participate in IEEE Extreme. So it is a bit hard, and those questions are a bit different than a regular question. So participate in those hackathons and practice more. And we have seen that even if you are going for an interview, you are practicing interview questions similar to competitive programming. So better you practice. And participate hackathons. That's the final point. Try to participate many hackathons as you can, because in your undergraduate you are just going to university and coming home and doing assignments. That's all. But what about the leisure time? So get some useful during your undergraduate studies. Participate in many hackathons, because after you graduate, you may not have those opportunities, because these are free, right? No one charging you. So participate in many hackathons as you can. And not only hackathons, other competitions as well, because it is good. So what is competitive programming? I should ask this question in the first slide. So what is competitive programming? I have given you the Geeks for Geeks definition, but I'm not into theoretical side. So basically, competitive programming means that you are given a problem. In I think your weekly program or the hackathon program, they have given you some set of questions in HackerRank, right? So let's consider a single question. What you are doing is writing a code. So this is the code, maybe C, C++, Python, Java, whatever the code that you are writing, whatever the language you are comfortable with, and you are writing it, and for the given test cases, you are evaluating against. So why test cases? Because to evaluate all the aspects in the problem. So there could be some constraints, there could be some limitation that you have to follow. So let's start with the problem. How to understand a problem. So first go through the question. Read the question, read the damn question multiple times. I have done that mistake a lot. I have made a lot of mistakes understanding I am solving my own problem rather than the given problem. So better you read the question multiple times, because you are not given time to answer your own question rather than the given question. So read the question multiple times and understand it clearly. And also, if you didn't understand, you can match with the outputs given. So they will be given at least one example. So go through the examples as well. Try to understand the question better. And most important, read constraints. So constraints are important because constraints, you may have seen a section called constraint, inputs, outputs, and the constraints. So the constraints means that if you are writing a code, that it may give some hints. Hints in the sense memory limits or maybe time limits. So with that, you may able to assume that what kind of code they would expect. Because if the execution time is smaller, then you can, even at the memory limit, you can think of a way that how to design your solution. So, and problem breakdown, after going through the question, try to break down the question. So the question breakdown means that try to get the abstract level, because every question in all the competitions have same pattern. There are common patterns that occur in all the competitions. So if you can understand the question and get the abstract level idea, then there will be some other unrelated stuff that make the question complex. Try to break down the question because of that. So this is where we were. So the problem was that, and we are writing a code and for a given test cases. So let's consider about the test cases. Let's jump into the code later. So with these test cases, some of they pass, some of they fail. Some of they pass because you given the correct output. But if we consider, some said in some cases you may get something like this, where some test cases passes, but some test cases fail. So what are the reasons for these failures? There are many reasons. So something wrong answer. So if you are given expected output is yes, but you are giving a no. So that is a wrong answer, but some test cases may still pass. So keep eye on that. The reason is there could be logical errors, incorrect handling of edge cases, and misinterpreted problem statement. So read the damn question again. So output format. So sometimes they expected an integer, but you are returning a float number. So better to go through the given output format that they expected to have. So instead of incorrect casing, like you are printing, yes, you are almost correct, you got the answer, but you are seeing your test case fail. So no point of, you are not getting points. So better understand, get the correct output format. So, and also floating point I mentioned, and also the mismatch in floating points. They might expect a 2 decimal, but you are giving without all the decimals. So that is something keep eye on. So runtime errors, there could be runtime errors during the runtime. So one common mistake is that division by 0. You may need to understand where the code fails. So you can use try catch, but I have rarely used in my journey. So keep eye on your division by 0. Invalid array indexing, you are accessing null pointers, reference exceptions, stack overflow due to deep recursion, floating point exception. So, and also this is very common in IEEE extreme conditions like IEEE extreme. So memory limit exceed because they are giving a limited constraint memory, and even in HackerRank I have seen that you are given a limited condition like memory limits. So you have to complete the code, run the code, and execute it within the given memory. So if you exceed that memory, then you will get this error. So because of that, try to minimize the errors. To minimize errors, there could be leaks, memory leaks, recursion is stack overflows, and storing larger unnecessary arrays. So if you are like stacking multiple arrays, be mindful of that. And time limit exit, this is also a common exception that we get in IEEE extreme as well as HackerRank or whatever we call it. So that is because inefficient algorithms, like I'm using this term, but I don't tell what this is. O(n) squared mean you are simply think like you are stacking 2 loops, one loop and an inner loop going through over and over. So it could be leads to O(n) squared. This is called time complexity. So try to avoid in 2 loops. I mean, one inside another loop is taking loops rather than try to go for a optimized way. So this is, if you know, this is O(n) log n instead of O(n) square time complexity. You try to do it and log n or less complexity basically. Inefficient or very large loops and poor input-output handling, especially Java or Python. So these are the errors again. So this is, we went through the problem. We didn't went through the code yet, but the test cases. So in competitive programming, we are doing a lot of mistakes. That's why we get these errors. And some common mistakes that I can remember are I'm not reading the question correctly. So again, read the damn question again. So and keep eye on taking modular, because in the question they have given some cases, take the modulus. Modulus, if answer, given modulus. So that is because to get the lower numbers rather than many big numbers. So you may miss the taking modulus, but you are getting almost correct answer, but you are forgetting this, and you are in some test cases will fail and you don't know why it is that. And read constraints, as I explained earlier. So with that, let's get our hands dirty. That means let's try to break down a question. So tell me and I forget, teach me and I remember, involve me I am learning. So that is Benjamin Franklin. So let's get a practical example. So this question you may have seen earlier. This was the first question I think they given to you in your first weekly or day hackathon program. So this question, let's treat the question first. So Sherlock considers a string to be valid if all characters of all strings appear the same number of times. It also valid if he can remove just one character at one index in the string. And the remaining characters will occur the same number of times given a string S. Determine if it is valid. If so, return yes. If otherwise, no. So I think you have gone through the question, so I will start to break down the question. So let's try to understand the question first. So what it says, let's go through the example given. So ABC is given, and what they are expecting is here, if you read the question correctly, they, the Sherlock, whoever, need to have a valid, he say a string is valid if it has the same frequency of each character. That means if a character has same number of frequency repeated each time, so it will have valid string. So if you get the frequency of these ABC string, so the frequency will be A will be repeated one time, B will be repeated one time, and C will be repeated one time. So is this a valid string? So this is a valid string because according to Sherlock. So because if all the frequencies are matching, then it is a valid string. We have to print yes. And if it is not, we have to remove one character and check whether it is having a same frequency. So this is one example they have given. I took this one, ABC, no, the above one. So let's get the next one, ABC. So the frequencies are, there is one A, one B, and two C's. So is this a valid string? So if you consider if the frequencies of the characters, unique characters in the string does not match, if it is not in the same frequency, then we have to remove one character and check whether it is matching again. So the C, there are two C's. So this is not valid at first inside because one A, one B, and two C's. If you remove one C, then we are getting the same frequency. So if you remove one C, then we are getting the same frequency. So it is a valid string. We have to print yes. So let's get another example that they have given. A, double B, C, D. So the frequencies, I took the frequencies like below. So is this matching string? Is this a matching string according to Sherlock? So you can check whether the all letters have the same frequency. So A repeated 2 times, B repeated 2 times, and C1, D1. So this is not a valid string at this point. So if we, that is because if you remove one A, you get one A, two B's, and one 1. So the 2 is invalid. So if you remove one B, then we are getting two A's and one B. That is also invalid. So we have to print no. That is the question. We understood the question, what expected. So there are constraints as well, function description and input output format. This is very important, a single string S. So we have to output S. S is given in the question as well. Whether it is question is either written, we have to return either yes or no. So let's say you don't know the code for this. So one lucky shot that you can give is just print yes or just print no. Without writing any code, you can do is print yes. So you will get some marks because some of the test cases either have yes or no. So if you write just string, it will answer some test cases. That's the tip if you stuck in a question. So let's break down this question. So if I'm you, I'm just taking the examples in the input space. So these are some of the input space that I took from the example. A, B, C, this is a validity string because having the same frequencies. And A, B, double C is also a validity string if we remove one C from here. And A, B, this also, I'm not going to read this, but if you see this, this is an invalid string and the next one as well. So if we get the frequency, now what we want to do is get the frequency, whether we are having the same number here. It doesn't matter whether this is 2 and this is 2. What we want here is the same number. So what if we get the frequency of this? So we got the frequency of this, how many numbers repeated, but what if we get the frequency of this, that means the second count. So this is letter count, so letter and the count, the letter and the count corresponding count, how many times it repeats. But if we get the frequency of the count, we can get some understanding. So I think you have done this question, but I'm trying to break down. I want you to understand how I'm going to break down this question. So how I'm approaching it. It doesn't matter whether you understand it or not, but what I want you to know is how I break down this question. So if we get the count of the frequency, okay, so there are 3 ones. 1 repeated 3 times here. And also if we consider this, the next one, 1 repeated 2 times. 1 repeated 2 times and 2 repeated 1 time. Likewise, we can get the frequency of each count. That means the next one, 2 repeated 1 time, and also here 2 repeated 1 times, 2 repeated 1 times, and 1 repeated 2 times. Likewise, the 1 repeated 2 times, 2 repeated 2 times, 3 repeated only 1 time. So with that, let's try to get an abstract level. Abstract level means this is more specific example level, right? This is only for this example. But let's consider what I request. Just replace this one. Whatever number we have here doesn't matter, right? Because 1 doesn't matter. It's just a number for us. But in our example, it could be any. Now I said this either 2 and 2 is also fine. If it is 3, 3, 3, it's also fine. What we need is to have the same frequency here. So in order to have the same frequency, what I just did was replace this 1 with a random letter, Lx, frequency of the number. So Lx, I first replace this one with Lx, and then the next one as well, I replace the one with Lx and Ly, just 2 random letters. Likewise, I replace all the letters, and for the 3 I replace Lz. There can be other letters as well, L, Z, L, P, L, Q. There are many samples that there can be many samples. So and also I replace the next character as well. Next character here means the 3. So Lx repeated 3 times. So here now that we have, I'm considering yes output space. So our input space under the ABC, we are expecting to have the same number here. This column, we are expecting to have whatever the number here, doesn't matter. We are trying to get the same number here. So in this space, what we are trying to do is get the same number of letters. So it will be Lx into n. This n can be 4, 3, 5, whatever. So that means if it is 4 means there are 1 4C. 1 4C means there will be another letter here. So that is means A, B, C or D, Z, whatever. So that is a yes number, right? It should be a yes because we need to have the same frequency. So likewise, I break down the next sections as well. So LX, the next one I replace it with n plus 1 and n. I will tell you why, because I replaced n plus 1 and n here because let's go to the next one as well. So this I replace with n plus 1 and n. That is because in this condition we are checking two ways and having one extra letter other than these two repeated ones. There could be instead of C there could be another D with two letters. So it could be A 2 times repeated, B 2 times repeated, and C 3 times repeated. So that is because if we remove C one time, then we get the output space yes. So similarly, that is why I mention n plus 1 here. So that is if we abstract level, we get Lx n plus 1 and Ly n space. So this is in the output space of yes. So similarly, we get the norm. So if let's think about this scenario. So there are two letters, two unique numbers, and there onwards we are getting the frequency of this. That means we are shifting from yes to no. That means if we have this Lx repeated 2 times and Ly repeated 2 times, if we swap with another number, just a letter variable in OM, it is not m is not equal to n plus 1, because if that's so, then we are getting the same output space. So instead of that, we are getting the abstract level m and n. Because if you think of an example in the reverse way, that means let's say here we are getting 5 and 2. 5 and 2 means here we have 5 and 2 and 1 repeated 5 times. That means 1 repeated 5 times means we are getting other samples as well. So that is in no space. And similarly, if the number of letters increase, that means if we have more from here to shifting here, if we have more frequencies, that means more frequency of count, 1 repeated 2 times, 2 repeated 3 times, 3 repeated 1 time. When we get more letters repeated many times, we are increasing the input space. So A, B, C, and we are getting more adding. If we consider this is string, this is a valid term, right? And if we add this one, then it is invalid. And if we add more to that string, that means we are invalidating it. Invalidating means going to the output space, no. So similarly, I added the frequency count as Lx into n or Ly into n. So now let's check the output. So consider the last line. Can you see a pattern? Before that, I will name these variables. So let's say character dictionary for this. This is input. This one step after breaking the string into this format. Let's say this character dictionary. And for this one, let's say count dictionary. Then next this one. So can you see a pattern here? Can you see a pattern in the last row? If you consider the last row, if the character, the count dictionary, so in programming languages, there are ways to store key value pairs. So there can be different key value pairs. So in Python, how we keep key value pairs is using a dictionary. So that is a key value pair. This is the key, this is the value. So in Java or C++, whatever, there are hash maps and other data structures. So in this line, if you see, if the count dictionary length is 1, that means if we have one row here, then that means obviously it is in the input space of yes. Compare this. So this is in the, this has the first line, and there are two lines. When it is get two lines, we are getting both yes and no. But if it is getting more lines here, we are getting to no output space. So so with that we can come to conclusion. If there is a length is 1, that means the count dictionary has a length of 1, it is obviously yes. You can see it in here. So because we abstract level, in the abstract level you can see that if it is only contain one element, then it is obviously a yes. Right? And if we move on, if we consider these two, then we have, if it is the length of the count dictionary is 2, then we have to think about it, because it can be either yes or a no. So, and if it is more than 2, that means 3, 4, 5, it is obviously no space. So we can come to this conclusion. So if it is 2, we have to do some validations, more validations. If it is more than 3, that means else, we are printing no. That is because obviously it is no if it is more than 3. So let's consider, now we need to have some validations there. So if it is 2, that means we need to separate these two. There are two rows here. We need to, some way, we have to separate these two rows. So how are we going to do this? So if I consider, the question given says is, it could be if it is not having the same frequency. That means same frequency is this line. Because if we add more letters, it is just having only should be one letter, because this is 1 and this is number increase, doesn't matter, so we are getting this input space. But if we have invalid string, that could be something like this, or if we have many A, B, C, D, E repeated 1 times and D Z repeated 2 times. So in that case, in an invalidated state, what we do is try to remove one and see whether it is valid or not. So basically the condition is, we are checking whether these two difference is 1, right? Because what we want to know is the difference between these two. If it is, in this example, if the difference between these two is 1, then we are getting a valid string, right? Based on that hypothesis, I am saying this. So the max means this one. In here the max means 2, right? And in minimum is 1. So if we take the difference between these two, it should be equal to 1. That is the that is how I interpreted that from the given example question. Question says if it is invalid, then we have to remove 1 and see. So that remove 1 is this one. So I am trying to remove maximum count from a minimum count and get the 1. So if it is 1, then I am saying yes. So is this correct? So my question is this correct? So we map the input and output space into a track level, but when getting the answer, is this correct? So in reality, like we build up a question like code like this, but sometimes use case may fail. So in that case, what we have to do is improve the code. So we may do some points, get some valid, invalid test cases. So in order to pass them, that is because some of the other conditions are not checking. So your entire test case some of the test cases passes, some fail, but some fail because you miss a point. Miss a point mean somewhere in the question that you didn't put into your logic. So if we consider another example, so similarly, I thought this is the this contains all the input and output phase. But actually, if I consider this is string, this should return no. But if we consider with this condition, so I'm not interested in this string, but let's take the character dictionary. So the character dictionary, you can see that A repeated 2 times, B repeated 2 times, C repeated 3 times, and D repeated 3 times. And the count dictionary contains this 2 repeated 2 times and 3 repeated 2 times. But if we put this string into this logic, of course this dictionary has more than 2. That means going to this condition, the length is more than 2. It is 2. So going to this condition and checking max count minus min count. That means 3 minus 2. That is 1. And we are printing yes, but the expected answer is no. So if you consider this string, if you remove one string from that, we cannot validate. So if you check the string, there are 2 A's, 2 B's, 3 C's, and 3 D's. If you remove one C, we are getting 3 2's and 1 3. So it is invalidated. We need to have the same frequency. So let's how to improve this code. So our test case is failing. This test case is failing. Why? What we need to do is improve the logic. So how do we improve this logic? So if we consider now why this is failed, because this condition need to be improved, because if you are printing yes, we need to check no. That means we need to print no here, but we are printing yes. But we need to add more logics to this condition in order to get validate no. So how do we do that? If we think of this scenario, we could have in this output space, yes, we could have repeated numbers A, B, C, D, whatever list of numbers repeated 1 time, and there could be another letter kind of Z repeated 2 times. So we all have 1, but if we remove 1 letter that having extra, we get the valid yes input. So because of that, if we think of that way, there are many 1s, and there could be another letter. Let's think about this example. There are 2 1 repeated and 3 repeated 2 times. So if we check this, if the max count is 1, that means others are repeated only 2 times. We can remove this 1. If I'm so let's jump into logic. So if the max count is 1, then it is obviously if the max count is 1, that means we can remove 1 element from the max count. Right. So with that condition, we are passing that string. So how did I know that string? I just randomly, my test cases are invalidating. Some test cases are failing. So because of that, I just randomly select a string which could invalidate my test code. So I thought this was the correct all input and output base, but there are inputs which are invalidating my code. Because of that, I need to think of a logic that improve my code. So with that, we improve the code. I want you to know the part of the thought process behind what I'm doing. You don't need to understand this question, but think of the way that I'm solving this problem. So let's take another example. We think this is correct, but we put the test cases, we get invalid. Invalid means with this string, this is printing a wrong logic. For yes, we are printing no. If you consider this, there are two ones and we repeated 3 times. So in this logic, there are 2 conditions. The length is 2, and if we can get the count of maximum, it should be 1. Max is not 1, and this logic is true. This logic is true, but if we consider this one, if the max count is 1, then we are in a we are not going to print yes because this is invalid. So we are jumping out of this if condition and printing no. So printing no means we should print yes, but we printing no. So that is incorrect. So there is somewhere there is a point that we didn't get. So this input space does not contain that logic that I need. That means that string I need to pass through these conditions and check whether where I am getting failing, where I am failing. So if you think about it, there could be places. Check this string. So you need to improve this code, but all you have is you found an input space which invalidates your code. So let's see the string. So if you see the pattern, the B repeated 3 times, C repeated 3 times, D repeated 3 times. All we want is to remove this A. It is a valid string, right? If we remove this A, the rest of this string is valid, but if we remove this one letter, we are getting a correct answer. So we are not checking that one here. So we are not checking that removing one here, the rest of the code is correct, rest of the string is correct, but if we remove this one letter, we are getting the correct answer. So let's add this logic. So here is 1, then the count dictionary, that means the minimum, this minimum should be 1. So check this logic. So the count dictionary, if it is count dictionary is 1, that means we are removing the extra single character. So think about the process that I went through. So for your reference, I didn't type code, but what I wanted to know is this logic section. You can build up the data structure that during the process. This is to use to build the data structure, but this is the actual logic. So think about the process that I went through. So first I got inputs. Think of an input space that could separate the logics. So I thought that my inputs are inputs and output space. I thought it could separate the conditions that I am looking for. But at the end, I couldn't cover all the logic that I wanted. But there are some invalid test cases. So because of that, I had to think of a failure scenario. So the failure scenario, I took a string invalidating my code, and with that I improved the logic. So this is how actual hackathon would look like. So you are building upon a logic, but input output space, you are separating logics, but at the end you are not getting expected outcome. So with that, I would like to give another example. So this is an example from IEEE Extreme. So let's jump into the example. So this is IEEE Extreme 15.0 question called Extreme Winners. So this is a different question compared to the previous one. The approach of this question is different from the previous one. So I cannot tell you give you a template of this is how you solve the problem, because in even maths you have a set of steps to solve a particular problem. But if you consider all the maths questions, there are different ways to solve a question. So that is that because of that, this is also the same. There are a lot of competitive programming questions. So we can give a template to solve. This is how you should solve competitive programming questions. So you have to practice more and gain the pattern, identify pattern. So let's go through this question. I will give you 5 minutes or 2 minutes to read through the question and understand. So go through the question first. So I will read the question if you can see the question. The question is, write a program that reads an IEEE winner team name and prints the number of competition edition they won. So write a program that reads IEEE Extreme winner team name and prints the number of the competition edition they won. So the program which correctly solve all 14 years being scored by the number of characters in the source code, the shorter the better. You must pass all test cases including the examples to get any points for this task. We are also making this incredibly easy for you by just giving you the chronological list of winners. So they have given winners each year. So IEEE Extreme, this is IEEE Extreme 1, the team 1 won. IEEE Extreme 2, team this name won. IEEE Extreme 3, likewise, each IEEE Extreme year, these are actually years, so IEEE Extreme years, this team wants each year. So how do you solve this problem? If you think this question, what they are expecting is they are giving one of these names, one of the names in the list, and expecting this value, the first column value. They are giving the one of the second column value, and we need to find the first column value. That's very easy, right? I mean, if I go through the inputs, they have given team 1, they are expecting this number 1. They have given Aurora 14, they are expecting this number 14. So, isn't this easy? The first line will contain the name of the team that won the past extreme, and the standard output. The first line of your output should contain a single integer between 1 to 14, that means 1 to 14. The number of editions, the number of the edition that was won by the team in the input. There are constraints as well. Team names are always provided as they listed above. So basically what they're saying is, if I give you what EVs, whatever, you should return 11. If I give you QSAT, then you should return 5. So how do you solve this question? I would like to have some inputs. So can anyone roughly say an algorithm to solve this? This is a very easy task. Can anyone? So let's go to the code. So if you think about the code, they are giving the list of names. So they are giving it, they are not adding it anymore. So this is the list. I replace this list exactly as same as this, on the code side, the other side. So what I have did is iterate through each, they are giving one name. So one of these names, I iterate through teams, this list, and find which index are we in. So if it is an index, then I return a print in the count. Each no. If you give me team name, what I do is I go through the list, iterate through 1, 2, 3, 4, 5, 6, 7, 8, and come to this. This is team 9. I'm printing 9. I'm counting and printing the number. So this is the code. So isn't it easy? This is a very basic, I think during first years you are writing this kind of codes, right? To find the a name in the list. So this is, if you submit this code, you will get around 1 point out of 10. 10, I would say 10. So you will get 1 point out of 10. Why? If you read the question correctly, if you read the damn question correctly, you can see the shorter, the better. Characters in the source code, the shorter the better. That means our source code is too lengthy. We have to compress it. So what do we have? It is already small. I mean, how can we compress it to a small code? Right? Here the concept is, if you think now, we cannot shorten this, right? I mean, using Python, of course, you can. But let's think about the data structure that we have. So we have a set of team names. So these team names. What we want to do is compress this data in a shorter form. So how can we do compress this data? So you can see the difference between this question and the previous question. So the previous question, it was like given sample outputs and we have to edit. And they are not interested in the code or memory, whatever. But here, in this list, how do we compress? Reduce the size of the team names. So let's try to go through one character. If the T is unique, if this first column is unique, that means we can replace entire string with one letter. Again, so if this first letter is unique for each team name, then we can replace entire team name with just a one letter, only a one letter. So easy. Where can we take a one letter and replace? So how do I think of this problem? Because we have a large, our code is now lengthy. We need to compress. So compress, we have given, we must include this data, because otherwise how can we find the given name is in the list. So we need this data, but we need to reduce the size. So because of that, I was thinking, if we can replace this entire name with a one letter, or two letter, or three letters. So if you consider one letter, T, if you consider one letter down across, T is repeated many times. So we cannot use T as the unique, I mean first letter as the unique to replace these names. If you consider 2, then TE, if you KN, so what I'm replacing means T1 replaced with TE. So we are not string, entire string this data structure, rather we are keeping only TE. So something like that. So if you try to do that, if you consider only 2 characters, then we are in trouble, because the TE repeated. So the same structure repeated, same name repeated. So if you think that team is repeated many times, so we cannot take up to 1, 2, 3, 4 characters. We cannot use 4 characters to replace this string. We have to take 5 characters, because if we consider this is a name, we have team, this is space, this is separated from this. If you consider entire string, then we can do something cut down after 5. So even with that, we are reducing only a small amount, because if you consider after 5, we are reducing only a small set of data. We are cutting off this side and we are keeping this side, but we are only keeping a small amount of data. So that is not efficient. So let's think in other way. So reverse way. What if we come from the reverse side of this thing? So reverse side of me, let's try to take the last digit. So 1, T, S, M. Likewise, if we take the last one, we can check S is repeated many times. So we cannot choose S as a unique name to replace a T name. If we like that, if we went through, we can see if we use 3 letters, we can see a unique name, unique 3 letters. So if I cut down the key name to last 3 letters, I get something like this. So you can see the code has a chain. So last 3 letters, you can see it is unique. So we can use this code to code and run and see. So I will explain the logic as well, since I have included it here. So here you can see we are taking the user input, and in Python, this is a shortcut in Python where we can take the last 3 digits. So if we put -3, that means taking the last 3 digits, characters from any string. So basically what we are doing is, from the user input, whatever they are giving, we are taking the last 3 string. That is what first line says. And I set a counter. I iterate through themes, this list, and if the user input matches if the user input matches one of these, I am printing count, and count I am increasing each time. So is this correct? Are we getting full marks? Are we getting full marks? Still no. Now we have reduced this large data set into 3 characters into 14. There is a huge reduction, but still we are not getting full marks. You would get 5 or 7, something like that. So why is that? So we need to optimize this. How? If we are optimizing it, then how do we do that? So if you think about the names, can we replace it with the 1 character, just the 1 character? So we try to replace it with the 3 characters minimum, but it didn't work. It worked, but not efficient. So we have to replace it with the 1 character. We have to try to replace 3 characters with 1 character. Not 3 actually. This team name representing 1. So if you think, let's think, I am multiplying each string by 4 times. It could be many times. Let's repeat these team names many times. Infinite, let's say. So in that strings, these strings, can we find a unique number in a column? In a column, can we identify a unique number which represents the team name? So if you, I consider only 4, because if I put many times, it will be all ordered. So why I choose 4? So in here you can see here, if we consider this column, this is 15 column. After repeating 4 times, you can see 15 column have a unique set of characters. That means that is our goal, right? What we wanted to do is replace this team name with the single character. So we are achieving it here. So if we repeat it 4 times, I mean 4 times, I choose 4 times because if you think these cases, if the shortest one is virus, so virus, it takes only 4 times to repeat. So that is why I choose 4, and you can see it is completely a unique string. So with that we can compress to something like this. So each name can be represented using this small string. So we had a large data, we compressed to that small string with 14 characters. So now we are good. So with that, how do we, I will explain the logic calculator, the rest of the structure. So what we do is take the user input and multiply by 4 because we need at least 4 strings. We need to have at least 4 strings repeated this 4 times to get the unique character. So here in Python, if you multiply a string by 4, that means you are repeating the string 4 times. In Python, you are repeating the string 4 times. So then what I do is I added a condition check here, but ignore that. So if we check repeated input, the 15th character, that is what we got, right? We repeated 4 times and we saw that the repeated the string 15th character is the unique character which represented T. So I'm getting the unique character 15 and finding the index in this string. So this is the unique character defined. Finding the string index of index in this string. So it is and printing the index. So are we good? If I submit this code, do I get full marks? I wrote an algorithm, it is correct, and I compress the entire this into a small 14 character, and is this correct? Still you won't get high full marks because we don't need these variables, right? Our goal is to reduce the length of the short source code. So in order to compress the source code, we don't need these conditions, we don't need user inputs, taking variables. So let's replace that into directory. So this shorter Python code do this task. So imagine we had a lengthy code before, but with that small single line, we are doing the task. Doesn't matter. We had a lengthy code and we are doing it using just a single line. And how this is the beauty of Python, because if I remove this user input variable and took it directly and multiply it by 4 and take the 15th index. And I find this operation, I did finding indexing this string. So that lengthy code, if I go back, this is place where we started. So this lengthy code, our goal was to compress the code, have the minimum number of characters in the code, and we got this. So looking back at the questions, you can find the link in here. If you are searching, you can search IEEE Extreme 15.0 Extreme Winners. The question name is Extreme Winners. Question name is Extreme Winners. If you are searching IEEE Extreme 15.0, search the question Extreme Winners. Okay, so looking back at this question, I got 2 approaches. This is a different question from the previous one. Different question means previous one, we break down the question and try to map input and outputs. But here, the question is easy. What we had to do was reduce the size of the source code. So the 2 different approaches and it is very unique to each question. So, and this is the beauty of IEEE Extreme. If you are participating, I am highly encouraged to participate because this kind of fun, right? Compressing all the whatever the number of characters into just a single line. So, do you have any questions? So, with that, I am coming to conclusion. So, important, try to break down the question. It depends on the specific. Based on the question, each question is unique, but if you try to abstract it, it is a unique code. And be mindful of test case various reasons, and don't forget to have fun. While you are doing the competition, have fun. Thank you very much.
Thank you so much, Mr. Ramindu, for that insightful session. We truly appreciate the knowledge and energy you brought in. Now let's keep the momentum going with our next speaker. Next we have Mr. Pasindu Bandarigoda, a senior software engineer at IFS. Mr. Pasindu brings deep technical expertise and a passion for innovation. And today he'll continue the journey by diving into more strategies and insights to sharpen your competitive programming skills. Let's welcome Mr. Pasindu Bandarigoda.
Hi, good morning. I'm Pasindu from IFS, platform team. I think you might know now better how to break down questions and problems better. So through the rest of part. Can you do you know about have you learned before about data structures and algorithms as a subject, or at least heard about them? Can you raise up those who have not heard about DSA? Okay. So, so imagine like clicking a button in a software application and waiting. So we all felt the like frustration of the program that lags or an apps that freeze, right? Because everyone don't like to wait to do your day-to-day things with lag. So in our hyper-fast digital world, so speed is not luxury, so it's necessary thing. So and whatever it's a web application or large ERP systems, so users expect fast, smooth, and reliable systems. So and behind the speed, are like how it's magic is behind the data structures and algorithms. So and optimizing the code. So about yeah. These are the content prepared today for you. Um, um, Imagine the RAM is like we have to when you doing the program, when you doing the programming, you have to think more about the RAM and CPU mainly, rather than the code execution, compiling success. You have to think always the RAM and CPU, how it's getting a load and how it's handling inside. Because when you choose, if you choose a raw data structures, so it will affect for your RAM and CPUs. So if it's mean it have if you're choosing a wrong best wrong data structure, so it will affect for the cost for companies. And if you use cloud resources or your on-premises resources, it end of the day it affect for your cost. So when you're using when you providing that kind of a service for your customers or users, you have to put that load for them, the costing load. So if the dangerous thing was like if someone use someone create the platform with using better data structures and algorithm, they may be able to provide same solution under low cost. So they can provide to users and customers the low cost and reliable, efficient product. So, uh, so, so you might, if that kind of situation, you might be lost that kind of user base for and traffic for your system, and as well as your web applications. So, if we are targeting like data structures are like foundation for how you program communicate with memory. So they are not abstract. So they define how real systems behaves, right? And like arrays are index rank. Like that you grab what you want instantly, and if I think the stacks and queues, so it's defined order. So first in, last out, and first in, first out, like that. And without data structures, everything is brute force. Like with them, everything is organized. And if we think with ERP systems, a simple mistake in how you organize order items or customer records, I'm taking like as an example, using the wrong data structures can create like slow down your systems. So what about your idea about the algorithms? So we use data structures for structure to organize the data. So what about the algorithms? So okay, I'll explain that. So let's think. We need to sort 10 million records. So it's a huge data, right? With if you use bubble sort, might work. It also work, right? For one, maybe will run 100 or 100 times. But in problem, it's we can use better algorithm than that for that kind of situations. So algorithms are not about writing the code, just writing code that works. So they are. It's about writing code that scalable and to executing your program in optimized way. So like sorting used for everywhere. So from like we can take an example like from invoices to dashboard, or some something you need to retrieve data for somewhere you want to visualize. Like searching, you can use for autocomplete, like and if I think like optimize code optimizations, it's for real world systems that needs to run fast and reliable and scalable, as I said earlier. So two functions can return the same answer. One's run 5 seconds, another in 5 milliseconds. Like in large scale environments, inefficiency the unstructured code wasting the CPU and memory. And in the platforms, okay, you think the ERP systems, these are cost compound across services, environments, and users. In competitive programming, it's I think you have the end of these sessions, you have hackathon. For that kind, you can break down that kind of problems and questions as said Hamidu in earlier sessions. So, but I'm trying to inspire you to think how we need to program when we are writing a program. What are the things we need to think other than the when you after properly break down those questions, you have to convert it to the code, right? To build your solution. So when you are building that kind of solutions, let's take you are answering us all one question in rank or IEEE Extreme or whatever. So at the end of the day, so you have to when you answering that particular question, you have to think the background of the all questions, and now you have to just think about the particular questions and targeting how you want to break down, and what are the data structures you need to choose and pick up, and what are the algorithms you need to use. But you are the guys who willing to enter the upcoming days to the industry. So this is not just for your theoretical, and this is not just for your hackathon. So this is how you need to think when you are working in industry, and when you are building your own system, or when you are starting your startup or whatever. So you have to think the three key things, like cost, efficiency, and reliability, when you building whatever the system or whatever you're contributing. When you are working at the working environment, your corporate or the startup, so you are contributing small parts, like in large application or the large system, you are contributing a small part. So it's same as like now you are going to solving the small questions. So but I'm trying to say, when you are solving small problems, but need to think whole system. So whatever the code you change, at least one letter, so you have to think how it's work with RAM and CPU mainly. So because like it's in let's take as an example in cloud environment. So we literally pay for the extra extra like extra you whatever you using resources. So nowadays we can implement the systems if you getting more load, you can enable the auto scaling and there's options, but you have to pay. So that's the thing. So there's options and solutions, but you have to write a code as much as you can optimize, because today you can also use the LLMs and the other platforms to write the day-to-day codings. But the key thing is how you can survive with this kind of world. Like now you have to think over the writing code. This type of like now you have to polish up your refresh your thinking rather than just writing code without executing errors. So the next session is I just pause. Sorry guys, I forgot to the slide slide forwarding. Yeah, you can see this video.
In many ways, our memories make us who we are, helping us remember our past, learn and retain skills, and plan for the future. And for the computers that often act as extensions of ourselves, memory plays much the same role. Whether it's a 2-hour movie, a 2-word text file, or the instructions for opening either, everything in a computer's memory takes the form of basic units called bits, or binary digits. Each of these is stored in a memory cell that can switch between two states for two possible values, 0 and 1. Files and programs consist of millions of these bits, all processed in the central processing unit, or CPU, that acts as the computer's brain. And as the number of bits needing to be processed grows exponentially, computer designers face a constant struggle between size, cost, and speed. Like us, computers have short-term memory for immediate tasks and long-term memory for more permanent storage. When you run a program, your operating system allocates area within the short-term memory for performing those instructions. For example, when you press a key in a word processor, the CPU will access one of these locations to retrieve bits of data. It could also modify them or create
this video will represent what I told so far. So, let's move to next slides.
In many ways,
These are the when we talking about the data structures, these are the basic thing before we need to talk variables. These are the key things before we need to think, need to discuss about discussing about the data structures. Like I need to tell you about the you have to assign define the variables in right way, because I'm trying to find. Give me a second, please. Yeah. I think when we assigning arrays, so we can I'll explain in detail in next slide, upcoming slides. So you know about these fundamentals of the programming, like encapsulations, inheritance, and abstract. I'm not going to explain about what's the abstract, what's the encapsulation and all. So I guess you know well right now. So let's move to data structures. First, we have arrays and lists. I'll show you with example. Are you guys visible? Or shall I increase the size? Right, guys, you can see. Okay. In here, you can see the we have number, and we assign array like 4 numbers, right? And I'll explain about this CPU and RAM allocations for this object. Like RAM finds 4 spaces, right? There's 4 numbers, 10, 20, 30, and 40. So it's assigning for 4 places inside the RAM. So its numbers is a reference like a label. So that's pointing to that location. So and CPU when we print numbers 2, right? CPU jumps to index 2 and directly calculates the address is address plus 2 and RAM sends value 30 back. So efficient access, 0 time for that. So like if it's like I'm just trying to explain what we when we assigning the numbers like that, what will happen inside the RAM. So yeah. If we move to stack, like we have defined a stack array and CPU allocates a new list like structure in RAM. So empty for now in beginning, and the stack appends A, and then CPU writes A into the first available position of the list, and then stack append B. So now B is placed on top of B comes the last inserted top of the stack, right? Then stack pop, the CPU removes the last inserted value, it's B, right? The brands make B space as free for ready to be overwritten. Before moving next one, I will show you this with animation. Let's see these stacks as well, since we have discussed about it. I'll explain about the queue on as well. And you can see that we have defined a queue. So when we assign define a queue, like CPU initialize a double-ended queue in memory. So unlike normal list, it's optimized for fast insert and remove at both ends. So as here mentioned, first in appending task 1 and task 2. So RAM adds task 1 and task 2 in order. Internally, head pointer and tail pointer manage the positions. So pop left, it's CPU reads task 1, first inserted one, and then shifts the head pointer forward. So and RAM now consider that slot reusable. Let's going to next one, linked list. First, we'll go through these simple videos. I'm just showing this video so you can just realizing the names and the behaviors like in generally. So because you can refer this, you can get this information through the internet and ChatGPT or another. You are getting knowledge. So, let's go for linked list. Here you can see the node class, and the node class is a blueprint. Nothing happens in memory yet. We just we have not executed. So yeah, and if we assigned these things, Give me a second, I will add assign these variables. A equal node 5. So CPU allocates memory for A, storing 5, and storing 5. So and A contains a data box and pointer box. So and B equal 10. New memory chunk is allocated for not necessary next to A. So and A dot next equal B means CPU writes the memory address of B into A dot next. So and RAM now holds a linked relationship A and B. So and go for recursion. Let's see first about it's a simple one. So is okay. The push and if I push a new frame for that into the call stack in RAM. So it's storing in values return address and local variables. So like when the base case is at the CPU pops each stack frame returning back up. So we can use this if you forget the base case. So the stack keeps growing so until it overflows. So that's the behavior of the recursion. Let's see a little bit about tree as well. based on your problem and question, you can choose whatever the best option for you. If we are going to explain about this, I'm explain with binary tree. So what will happen inside of binary execution, this type of code. So the there's a separate nodes there. So RAM also dividing it for 3 separate nodes, and there's a, you can see the root dot left and root dot right. So store these are the stored memory address of child nodes. So and it's jump from nodes to node to node using those addresses, and push and pop nodes from the call stack during it's it's also best you can use example. Yeah, I will show you with this in video. So before moving to that, I'll explain with this how you choose, how you think with this example when you solving the hackathon problem, and you can provide, you can have a better, you can write a better code. Like you can see this in first code segment. I'll separate those two. You can see properly, identify it clearly. You can see the here it's like counter is right in second part. Counter is loops over string ones, and update hash map. So it's allocating RAMs like it's like this. Explode. Like this. But in dot value, it's retrieves only the values from map. So it's allocating like just an array. So set up frequency values in second one, this part, it's duplicate in the RAM, and second and third stored as a hash set. So, and if you write the same code with first method, it's wastage for it's consuming a more RAM capacity. So you can use the same thing like this to reduce the RAM wastage, and you can use this type of code for your solutions and your day-to-day programming. So this part also executing and working fine, but this is the better one for to reduce and optimize your code. So whenever I just wanted to highlight, like when you writing code with LLMs or AIs, you can when you explaining when you prompting, it will maybe providing this type of code. But if you have a knowledge to write this type of code, or if you have a knowledge to realize this is a wastage, so you can at least prompt properly for AI to getting and generating this type of code. So we don't want to writing without code, without AI or some LLMs, but you can use it as a tool, but not not giving your control for that. And let's move quickly for the stuff part. So it's sortings. You can see this bubble sort, how it's sorted. These all are sorting methods. the last one. So, yeah, the next algorithms for searching. This you can see this video to get better idea of that. This extended next video for saying yeah, this is analysis of algorithm performance. I will explain with video because performance is one of key facts that I told you in once I started this session. So let's go.
There are often multiple ways to solve a problem. How do we know which solution is the right one? And how do we compare one algorithm against another? In order to analyze the efficiency of an algorithm, we generally use a technique called big O asymptotic analysis. The definition of big O is f of x is in big O of g of x if and only if there exists a k and an x naught such that for all x greater than or equal to x naught, f of x is less than or equal to k times g of x. Easy, right? Well, let's dissect this to understand what this is saying and how this is useful. The big picture is that we're trying to compare how quickly the runtime of algorithms grow with respect to the size of their input. We think of the runtime of an algorithm as a function of the size of the input, where the output is how much work is required to run the track material at the start, but there isn't any set on the race course. What this means is that in order to move forward, the train needs to go back to the start, pick up the next bit of track, move forward, place the track down, and repeat. For simplicity, we'll say that the train can hold one step length of track at a time. I won't prove it here, but in order to progress n steps in the race, this train needs a total of n squared steps, or a quadratic amount. A linear racer might seem slower than a quadratic racer at first, but as we get far from the starting line, a linear racer will pass the quadratic racer, and its lead will grow forever. Even a performance boost can't make the quadratic racer faster than the linear racer. We can imagine slower racers, such as those that take big O into the third or big O into the fourth time. Often, we like to group together all algorithms that have the big O of the form n to the k under the term polynomial time, since the runtime is a polynomial function. The reason is that different computational models can result in different big O runtimes, but a polytime algorithm will always be polytime, regardless of the machine model. However, we can get a lot slower than polynomial time. Imagine a racer that is using the race as an opportunity to train. The racer will take a step forward at first, but for every new step, he goes back to the start, repeats everything he did before, and then takes a new step. The time it takes to make each new step essentially doubles every time, giving us a lifetime of big O of 2 to n. We call these algorithms exponential, and even if we kickstart them to begin quickly, they rapidly slow to a crawl. While we could find infinitely slower algorithms, there are some really fast algorithms to explore. For example, let's think of a racer that can teleport. What this means is that it will always take this racer the same amount of time to travel any distance. We call this runtime big O of 1, or constant time. This big O covers all teleportation, whether it takes 1 second or 1 million years. We can also imagine a rocket ship that accelerates faster and faster the farther it travels. With each passing unit of time, it can travel twice as far as it did before. This behavior is the inverse of the exponential algorithm. This is big O of log n, also known as the logarithmic function. So far, I've been talking about increasing the input size like it's the only factor on the runtime, but the runtime of an algorithm often depends on the specific input. Some inputs can cause an algorithm to run better or worse, even if they're the same size. For example, if you're trying to find a Charmander in a pile of Pokeballs, you could get lucky finding it in the very first Pokeball you open, which is a constant time operation. But sometimes you have to search through every single Pokeball before you find Charmander, which is a linear time operation. It's often helpful to separate an algorithm's runtime based on what happens in the best case, the average case, and the worst case. But we usually take the pessimistic view and simplify an algorithm's runtime to its worst case behavior. Big O is also useful beyond just looking at an algorithm's runtime. We can use it as an analysis to how much space an algorithm is using, which is especially important if we have hardware constraints or are operating on very large sets of data. We can even use big O as product analysis on problems themselves, showing that it's impossible for any algorithm to solve a problem faster than a certain runtime. While big O is important and certainly useful, it isn't the end-all be-all.
these are the references I have created this session for today, and you can also refer these resources to explore more. And the last, I have to say, like, when you solving a problem and when you coding, you have to uh, ask yourself 5 questions. Like, the one is am I using the best data structure, and is this the right algorithm for that particular solution, and am I writing the code that scales, and am I thinking about the systems, memory and CPU, and am I making this efficient or expensive? So those are the 5 questions you need to think whenever you coding. So the best, if you have to think like engineers, not just simple like a programmer or ChatGPT coders. And you have to like solving good problems in a better way. Like, you have to think always, keep in mind these key principles and things, and so so then you can writing yourself code, and you can use the tools to optimize your code to build efficient code with minimum resource usages and with high performance system. So these are the things I just wanted to tell you today. Thanks guys for staying, and best wishes. I wish for you to do a successful hackathon at the end of the sessions. Yeah. Thanks guys. Have a nice day.
Thank you so much, Mr. Pasindu Bandargoda, for that insightful session. We truly appreciate the knowledge and energy you brought to it. On behalf of the entire CodeRally team, I'd like to sincerely thank Mr. Pasindu Bandargoda and Mr. Ramindu Valdemar for sharing your insights with us today. As a token of our appreciation, we'd now like to present a small memento, a symbol of our gratitude for your time, energy, and expertise. I'd now like to warmly invite our event chair, Gisal Bandar, to come forward and present the tokens of appreciation to our esteemed speakers. Let's give another big round of applause for Mr. Pasindu and Mr. Ramindu. Now, before we wrap up, we'd like to extend a heartfelt thanks to our amazing partners whose support made CodeRally 6.0 possible.
Artificial intelligence will impact all of our lives and how we work. IFS.ai is industrial AI. It's the thread of intelligence flowing through your business in a world where data is everywhere and informs the lifeblood of your company. The thread that powers decisions made by humans or machines. The thread that revolutionizes your operations, optimizing your people, assets, and service. The thread that enables the world's most progressive organizations to contextualize intelligence, simulate outcomes, automate production, and drive innovation across your business at pace, safely. We're going beyond co-pilots. We're powering intelligent business. IFS.ai, industrial AI that enables your business to thrive and grow.
When a company takes care of its employees, employees always take care of the company in return. This company values honesty and always thinks from an employee's perspective. All the good things that we've done so far has been a suggestion from an employee. So one of the things that makes CalC a great place to work is we respect all our employees, irrespective of the designation. So if you take Danushka, who's our CTO, who has been with us from the inception, or else an intern who has just joined CalC, the ideas, opinions, suggestions would be given the same value. And I think that's one of the reasons why people always come back to CalC.
wonder එක be the wonder.
දවසම පිනවන වෙනම ලෝකයක් Pearl Bay බණ්ඩාරගම ඩේවිඩ් පීරිස් සමුව්‍යාපාරයට අනුබද්ධ ආයතනයකි.
Artificial intelligence will impact all of our lives and how we
We'd like to extend a heartfelt thanks to our amazing partners. First, our strategic partner, IFS. Thank you for your continuous encouragement and for powering innovation in our community. To our bronze partner, DMS Software Technologies. Your contribution helps us take CodeRally 6.0 to new heights. A big thank you to Acceler, our supportive partner, for inspiring us to push boundaries. Our hackathon partner, Kelsey, thank you for championing creativity and the spirit of competition. Shout out to Pepsi, our official beverage partner, for keeping everyone refreshed and energized. Thank you to Wonder, our official snack partner, for making sure no one goes on an empty stomach. Thank you to Pearl Bay, our gift partner, for bringing extra excitement to our event. Thank you to Lumora Studios, our official media coverage partner. And last but not least, Lumora Frames, our photography partner. We appreciate you capturing all the memorable moments. Let's give a big round of applause for all our partners. So thank you for joining us today. We are thrilled to have you on board for CodeRally 6.0, and this is just the beginning. So we have our main event coming up. Before we conclude, let's capture this moment together with a group photo. We kindly request that everyone come to the front so we can take a group photo with our team and the speakers.